Hi everyone. I'd like to talk about an example about conducting hypothesis testing for a population proportion. So here are the 5 major steps that you need to show. So we have a manufacturer considers his production process to be out of control when defect rates exceed 3%. In a random sample of 85 items, the defect rate is 5.9%, but the manager claims that this is only a sample fluctuation and production rate is not really out of control. At the 0.01 level of significance, test the manager's claim. So the manager's claim is that the defect rate is not really out of control. So in other words, it means the defect rate does not exceed 3%, or equivalently, the defect rate is less than or equal to 3%. So we can put that into our hypothesis. So because the manager's claim is that the defect rate is less than or equal to 0.03, so because it contains equality, so we put that under the null hypothesis. And the alternative hypothesis will be the complement of that, which is p greater than 0.03. Now in this class, for finding the test statistic, we only consider strict equality under the null hypothesis, which is p equals 0.03, and that's the p you will need to plug into the test statistic formula. Okay, so that's the hypothesis. So you just need to have the one on the right. So then here's how we find the test statistics. So p hat is the point estimate, which is the defect rate we got from the sample of sample size 85. So that's the 5.9%, and p is the defect rate under the null hypothesis. On the denominator, we have pq over n, so this p is still the same p under the null hypothesis, and q is the complement of that, which is 1 minus 0.03. So be very careful that on the denominator, you use p and q. Do not use p hat and q hat. I have seen many mistakes like that in the past. Okay, so your n is the sample size, which is 85. So the test statistic is then z equals 1.57. So now find the p-value or the critical values. So in the test, I will just ask you to find either one of them. You do not have to do both in the test. But here I like to talk about both of them so you know how to do both of them. Okay, so the p-value is the probability where z is greater than 1.57. 1.57 is the test statistic. And the reason why we look for the area where z is greater than that test statistic is because this is a right-tailed test. And the reason why this is a right-tailed test is because under the null hypothesis, we have a greater than notation. So if you're not sure why is that, go back to section 8.2's notes. Okay, so the p-value is 0.0582, and the critical value would be 2.33. So because this is a right-tailed test and given alpha or the level of significance is 0.01, so 0.01 is the area on the right tail. Okay, so based on that, we can find the critical value z equals 2.33. Okay, so in case you don't remember, let's use our calculator to find this, because we talk about similar examples like this. Finding the probability or critical value in chapter 6 and 7. So first let's see how to find a p-value. So go to second, vars, and then select normal CDF. So lower bound is 1.57, and the upper bound is a big number, so let's just put 10 to the power of 10. Okay, so then that's the p-value, 0.0582. And then for the critical value, so we go to second, vars, and select the third option, INV norm. So be careful, this function takes cumulative probability from the left up to the critical value that we're looking for. So here we know the right tail is 0.01, so that means the left tail or the area on the opposite side will be the complement of that, which is 1 minus 0.01. So that's 0.99. Okay, so that's how I get the critical value 2.33. So after this is done, now making the decision. So we can use either the p-value method or the traditional method. So again, in the test, I will only ask you to use one of them, but you have to know how to do both in case I ask you either one of them. And here I like to talk about both of them. All right, so the p-value is 0.0582, and we compare that with our significance level, which is alpha. So we see the p-value is greater than alpha. So that will lead us to fail to reject the null hypothesis. And if we use the traditional method, then we like to see if our test statistic falls into the critical region or not. So since it's a right tail test, the critical region is on the right tail. In particular, is the red shaded area. And the z-score is z equals 2.33. So we see our test statistic is 1.57, which is not in the critical region. So this also leads us to fail to reject the null hypothesis. Okay, so again, if you don't remember what the decision criteria is, go back to section 8.2's note. So finally, draw the conclusion. So there is not sufficient evidence to warrant rejection of the claim that the production is not really out of control. So section 8.2 also have a template of how to draw your conclusion. So if you don't remember that, go back to the note in section 8.2 to see that there. Now I will provide that template in the test, so that will help you get started with drawing the conclusion. But more importantly, after you start with a template, like in this case, there is not sufficient evidence to warrant rejection of the claim. So that's the template for this case. Because first of all, our claim is under the null hypothesis, and our decision is failed to reject the null hypothesis. So that's the template we start with. Then after the word claim that, then you fill in the rest by the problem. So the claim in the problem is the production is not really out of control. Okay, so that's it.